Hi folks, we're going to talk a little bit about what's called the electromagnetic spectrum. So, kind of a quick little recap here. Electromagnetic waves are what we typically sometimes just call light. What is it? Well, it's both a wave and a particle kind of at the same time. Characteristics of waves. Waves have a certain speed, which for radiation is c, 3 times 10 to the 8th meter per second. Waves have a frequency and a wavelength. And by the way, the frequency, wavelength, and speed are related by this relationship. C is equal to frequency times wavelength. It's a very important equation for studying electromagnetic radiation. From a particle sense, light is what we call photons, or made of what we call photons. So you can think of light, I like to think of light and radiation as a stream of particles called photons, and the photons themselves have a frequency, a wavelength, and by the way, an energy, which is directly proportional to the frequency. Or what I mean by that is equals a constant times the frequency. And again, that number there, the h, that's called Planck's constant. This numerical value is not important for this discussion, but what is important is recognizing that the energy is related to the frequency. High energy means, or high frequency means high energy. Low frequency means low energy. Now, the range of electromagnetic radiation, frequency-wise, there's really no lower or upper bound. These numbers can be anything from basically 0 to almost infinity. And the different types of radiation are classified according to their frequency and wavelengths, and that's what's referred to as the electromagnetic spectrum. So what I'd like you to do right now is hit pause, get your book out, and turn to page 312. There's a picture of the electromagnetic spectrum there. You might want to get that out for this discussion. I mimicked it as best I could, but the book's picture is a little bit better than mine. So first of all, let's talk about kind of this classification. On the top are the different frequencies. And the lowest frequencies are on the left, the highest frequencies are on the right. So as we move to the right, frequency is increasing. Now it's important to note that energy depends on frequency. So if the frequency is increasing, so is the energy of a given, the energy per photon. Now, frequency and wavelength are related according to this relationship. And remember how this thing works. Because c is a fixed numerical constant, 3 times 10 to the 8th meter per second, when the frequency is high, then the wavelength is low. And when the frequency is low, then the wavelength is high. So the left end of the spectrum here represents low frequency, low energy, long wavelength. As we move to the right, we are increasing in frequency and energy, but decreasing in wavelength. Okay, so over on the right-hand side is the highest frequency, highest energy, lowest wavelengths. So as we go through these different classifications, on the left-hand side, the lowest frequency type of radiation is called radio waves. We are constantly bombarded by radio waves every day. Radio waves are used for communication. They're used for data transmission. We are constantly bombarded by radio waves 365 days, 24 hours a day, every second of our lives. And not just from earthly sources. There's all kinds of radio waves in space, and we're going to talk about why that is later. As we move up to higher frequencies, the next common type of classification are called microwaves. So microwaves are a little shorter wavelength, but a little higher frequency, a little higher energy. Most people are fairly familiar with the term microwave oven. Well, a microwave oven is effective, but not for the reasons you might think. Microwaves are still relatively low energy waves. That's not why they're used. Microwaves are used because water absorbs microwaves very effectively through a process called resonance. So when you heat something in a microwave, you can heat water or dishes that are relatively wet or have some water in very effectively. But if you try putting a cracker in a microwave, it doesn't work so well. So that's why microwaves are used, not because they're high energy, but because water very efficiently absorbs their energy and brings the temperature up. The next highest classification of waves is what's called the infrared region. I just put IR here. Infrared radiation is the type of radiation that we can feel very easily. You can feel IR radiation. We normally interpret that as what we call heat. You take one hand, like this, and just kind of place it close to the top of your oven. you'll feel the warmth on the top of, like, my left hand right now. That warmth is coming from the right hand. And that's because a human person radiates lots of energy in the infrared region. So what you're feeling is radiation coming off your body that's in the infrared region. People radiate energy at about 80 watts. Everybody watching this video is radiating infrared radiation at about the same rate that a light bulb, an 80-watt light bulb, gives up energy. Now, the reason we don't glow bright is kind of twofold. One, our eyes can't interpret infrared anyway. But two, a light bulb, all of that radiation is coming from one tiny little spot, so it makes that spot very, very, very bright. However, for a person, all of that energy is coming from, basically spread out all over your body. So any given spot is not significantly bright. If we had a classroom of people, we turned off every light in the place so that it was completely dark, and we all had infrared detectors, the place would be glowing very brightly. Every one of us would be very, very bright through the infrared detection system. All right, next highest frequency. This small sliver here, this is a very important sliver in the EM band called the visible spectrum. This is the spectrum of electromagnetic radiation that our eyes can interpret. And if we take that band and kind of blow it up, on the left-hand side is what we call red light, and then you got orange, yellow, green, and on the right-hand side is blue or violet light. One thing I'd like to point out here, red is on the lower frequency. So red is relatively low frequency, long wavelength, low energy. Blue is the higher energy. It's the higher frequency, lower wavelength, and higher energy. And these together, all of them are what we call white light. That's why you can take like a prism, and you can take white light and shine it through the prism, and it'll spread it out according to wavelength. And you'll see the rainbow. The next highest radiation is called the UV region, which stands for ultraviolet. Now, I just kind of put a little qualifier here. Once you get into the UV region, now you're talking about reasonably high energy. UV light or UV radiation has a high enough frequency and a high enough energy that it can actually start damaging cells. So when you start getting lots of UV exposure, that can be a little bit of a problem. You always want to start being very careful about radiation from about this point on, because UV exposure too much of it can be bad. The next highest energy, X-rays. Right? And everybody knows what X-rays are used for. They're used for medical exposures. Now, one thing about X-rays, they're very high frequency, very high energy, very short wavelength. The reason they're very useful is because they're very high frequency, very high energy, they tend to go right through material very easily. If I take a single X-ray photon and somehow shot it at a person, the odds are it'll just go right through the person and not interact at all. However, where the person is more dense, like bones and such, the X-ray will be absorbed, and then you get like basically a shadow on the wall. We're going to talk more about that later. So X-rays are relatively, they're very high energy electromagnetic radiation. And then the highest on the list is gamma rays. Gamma rays are the highest frequency, the highest energy radiations that there are. Now, I've drawn kind of these lines between them. One thing I want to point out, there's no hardcore cutoff between some of these. It's not like, if you're, 10 to the 25th, you're UV, but if you're 10 to the 25th plus 1, now you're an X-ray. These are kind of soft lines between them. There's overlap. There are frequencies that are generally called UV or X-rays. For you folks, the important thing is everyone in this class should be able to name all the different types of radiation. You should be able to list them in order of increasing frequency, or increasing wavelength, or increasing energy. So, hope you enjoyed that, and have a good day.